Hello, my name is Nader Dabit. I'm a developer advocate for AWS Mobile, and today I'm going to be talking about building serverless mobile applications with React Native and AWS Amplify. Um, so, if you want to follow me on Twitter or on any social media, Twitter, GitHub, and Medium, I'm Dabit3. I do a lot of tweeting, write a lot of blog posts on Medium, and I put up a lot of code on GitHub. So whenever I'm demoing something, I typically put a repo up and kind of like contribute to it and update it as I go and stuff like that. Also on Medium, I have a couple of publications that I work with. So Open GraphQL is one of them. GraphQL is becoming pretty popular. Open GraphQL is probably one of the more read GraphQL publications on Medium. And also React Native training. So if you're interested in React Native, you can check out the blog there on React Native. But today I'm going to be talking about, I'm going to be doing my demo at the end on using React Native, but some of the stuff that we're talking about today applies to pretty much any platform at all. And to kind of give you some context to where I'm coming from and how I got into this, I'm going to talk about my career and how it pertains to React Native a little bit. And then I'll talk about how that made me move my career in the position to where I'm working now with AWS. So when I first started becoming a developer as my full-time job, I was 29 years old. I had not taken any classes for coding. I had never done really anything pertaining to technology at all until I was 29. And in order to compete and to kind of get up and running with other developers that I was around, I was really looking out for different philosophies, techniques, and things like that that I could kind of use to kind of maybe get a little head start on some of the people that were younger than me that were already doing this for 10 or 15 years. And one of the things that I saw that was really consistent across more of the advanced developers is they were really always really trying to focus on efficiency and trying to use their existing skill set to do more things and kind of take what they already knew and apply it in a bunch of different ways. So I took that philosophy when I first started coding, and I've always kind of used that. And when React Native came out, I was a JavaScript developer. And with React and React Native, you can use React and React Native to build across all these platforms now. So there's iOS and Android, of course, but there's also web, desktop. You can write for Tizen and Apple Watch and Apple TV, and a bunch of other different platforms keep coming out. And in that specialization of React Native, I ended up getting a lot of people reaching out for training. So I started working with different companies, and I ended up opening a company called React Native Training. We still do React Native training. Over the last 2 years, we've worked with companies like Amazon, Microsoft, Salesforce, Visa, American Express, different entertainment companies like Warner Brothers. We've also worked with medium to small size companies and startups. And working with these companies, I've also noticed a key thing that they're looking for when they bring on specialists like us to come in and show them how to build applications more quickly and more efficiently, is they're worried about efficiency as well. And a lot of their teams are native iOS and Android developers. And in the United States, and I'm sure here as well, it's becoming harder and harder to find really good iOS and Android developers. Not only are they rare, but they're very expensive. In the West Coast in the United States right now, a really good senior iOS or Android engineer is making around $350,000 a year. And most of the time when one of the big companies like Apple or Google or whatever finds one of these engineers, they're making so much money and they have so much money tied up with stocks and stuff, they're never leaving that company. So it just ends up being a real problem. And one of the problems that React Native solves for certain applications, not for everything, is that it allows JavaScript developers who are less expensive and more abundant build mobile applications. And a lot of the companies that we worked with, we only kind of not only worked with their JavaScript engineers, but we also worked with their iOS and Android engineers. And we kind of helped them build teams and things like that. But one of the things that they're really focused on is getting their applications built faster, getting their applications built cheaper, and just being more efficient in general. And this got me to thinking really about the efficiency and productivity and this idea of the 10x developer. And I don't really like the idea of the 10x developer. I always kind of find it's kind of like a dumb topic to talk about, really. But I do meet people and I see people that are just way more efficient than me. Like if I see an application that someone like builds that I'm trying to think about in my head, like how would I do this? And maybe it would take me a year to do, and they've done it over the course of a weekend or a week. I mean, there are people out there like that. They may be few and far between, but they exist. And you know, it's hard to compare yourself to these people, you know, sometimes. And maybe you are one of these people. But I don't really like to focus on this idea of the 10x developer, but I do believe in the idea of 10x developer velocity. And developer velocity and making yourself more efficient is taking the existing skills that you know and applying those across different areas in your expertise. And that's kind of why I joined AWS Mobile as a developer advocate and to also help them work on some of the tooling that we're building right now. I still get to work with React Native training. We still take clients. I have consultants that work there. But I also help AWS Mobile and work on a couple of different things that I'm going to talk about around helping developers become more efficient and take their existing skill sets and apply them across different areas. And two of those things that we're going to talk about today are AWS Amplify and AWS App Sync. So AWS Amplify is a combination of a couple of different things. One of them is a CLI, one of them is a client library, and AWS App Sync is something that's basically a managed GraphQL service. A lot of people like to compare it to other managed database services that are out there. We're seeing a lot of people pick it up. The two main reasons that people are using AppSync are if they want something real-time with real-time data. So if you need something that works real-time, it has real-time capabilities baked in, but also offline functionality. We have a client that has offline baked in as well. So you can basically take this service, have an API up and running that you don't have to worry about, and then have real-time and offline capabilities baked in. And really, the two things that I'm going to be focusing on for the most part are the client and the CLI from AWS Amplify. And the main goal behind this project is to help developers build apps more quickly. And we kind of take on the worry of the back end and let you kind of worry about the front end. And really, all of the services that we're going to be talking about are going to be around this idea of serverless and managed serverless, I guess you would say. This is a really interesting quote. Serverless thinking: use a service whenever possible, because services are almost always cheaper than people. And you could also say more efficient, faster than people if they're a decent service. And when you talk to different people about serverless, you start hearing different definitions of serverless. And then you'll have, of course, someone that says it's not serverless because they're servers. And you might want to just take that person to the side and just whatever, you know, don't let them in the conversation anymore because you want to have a real productive conversation. But I'm going to talk about serverless today in a different context, I think. A lot of people, when they think of serverless applications, they're like thinking of a Lambda function here, calling a Lambda function here, and then there, and you have 1,000 Lambda functions. That's kind of not the ideal serverless application. This is a nice tweet that Joe Emerson tweeted out, and this is a really interesting guy to follow if you're interested in this stuff. Instead of a collection of functions calling each other, the best services have serverless applications have three main components: thick client code handling all interaction logic, heavy use of managed services. Managed services are what I'm going to be focusing on in just a moment, but a few examples are AppSync, Cognito, Auth0. Auth0 does authentication, of course. You've probably seen that out there, if not used it. Algolia is a really nice managed search service. Cloudinary. And then the third that's the actual serverless function. So small glue functions to tie everything together, where these actual managed services are not getting the job done. Then you use a serverless function to kind of get that last piece of functionality into your app. Another quote from Joe Emerson, and again, this guy is really interesting to follow. He's really has some interesting thoughts around this space. He's created, built, and sold multiple companies using this philosophy as well. So he also has a track record of being proving himself in this space. The key benefit of serverless is not no servers to manage, it's almost no backend code. So how do you build an application with almost no backend code? That's the question that we're going to kind of talk about today. And when I talk about serverless, the way that we're going to be able to accomplish the almost no backend code is by taking advantage of managed services that get the job done for certain things. And as the software industry progresses and more abstractions are built, we're seeing more and more managed services that do actually get the job done for a lot of things. And we're going to see more and more of those in the future. And I think there's like a new category emerging here. This is kind of my own take on it. There's serverless, there's managed services, and then to me there's something emerging that I'm going to call managed serverless. So what does managed serverless mean? No server operations. You don't have to deal with your server at all. It's there, it's up, and it works. If it doesn't, it's on your provider, be it AWS or be it Microsoft or be it whoever. It scales seamlessly. You don't have to deal with a million users coming online and crashing your server. Everything works. Codeless, that means we handle all of the backend code, or the managed services that you're using, they manage the backend code for you. You're just subscribing to an API that they've built and that they're managing for you. You don't need to manage uptime either. And basically the bottom line is it assumes a set of responsibilities for providing a defined set of services actually. So it basically gives you a service and assumes responsibility for that service. So what are some benefits of using a managed service that are going to be kind of the same category that we're going to be talking about? Well, first of all, you can get variable expense as opposed to capital expense. So if you've ever built a service or built a feature and you've had to pay someone for that feature and they've either billed you hourly or they've given you a fixed rate, you might pay $50,000, $100,000, whatever for that piece of functionality. You don't know if it's going to work. You don't know if this is going to be a good feature. You haven't really been able to test it because it's a new idea. You're kind of playing around. You still have to pay that money to get that feature out. The idea with variable expense is you use a feature that's already there and you build your application on top of that, and you don't pay for that service. You don't pay for that actual functionality until you get users. So the idea is similar to the way that you would have thought of when cloud computing first came out. And you can take this even further back and think of electricity. When electricity was first introduced as a technology, companies that needed enough electricity to run their power plant or run their factory actually had to handle their own power plant and had to build and maintain their own infrastructure around their own power. As technology progressed, we were given electricity as a service almost. So now whenever we need electricity, we don't have to deal with all of the underlying infrastructure. We don't need to know how to build our own power plant, right? We just flip on a switch and we get a bill in the mail at the end of the month, and that's what we're paying for. Down the road and now with some of these services, you can actually use some services in the same sense that you use electricity. So you're basically just paying for what you use and you don't really have to worry about what's going on underneath. Also, less code. So code is a liability. Whenever you make a change, you have to deal with the actual change in your code, of course. When you hire a new engineer, you have to onboard them with your existing code. If you have a bug, you have to deal with that bug. You know, just code in general is a liability. The less code, the better. This is kind of like my 3 steps of what I feel is good code. So clever code, I'm not a huge fan of that. If you write something that I have to really think about, even if it's like 2 or 3 lines less or 10 lines less of what you could have done because you're trying to be clever, that's not cool. I'd rather it be clear. But of course, down the road, the best type of code is no code. So if you can erase some code, that's even better than having clear or clever code. And then elasticity, I talked about how scaling is like a big deal. Again, if you have to worry about building something and not knowing if it's going to scale, once you do hit that point where your application is successful, you don't have to actually worry about dealing with scaling your servers. These managed services will do that for you. And then maintainability. Whenever you, again, have this application and it becomes successful, you may or may not be doing the work on this application. You may be passing it off to another engineer, or maybe you're even higher up in the company and they have an engineer that's then managing it to another engineer. And there's a good quote from Peter Lynch: go for a business that any idiot can run, because sooner or later, any idiot probably is going to be running it. And this is if you're shooting for a successful business, though. This isn't like something that you're shooting for if you're just playing around. I mean, if you really are building something you believe in, you want to make it manageable down the road, right? So again, simplicity is very important, and having something that anybody can come on and get up and running with is very important in the long run, also if you're thinking about selling your company. And then experimentation is at the core of what we do, I think, at AWS. We allow people to play around with things, build things, spin things up, and tear them down if they don't work. With the idea of variable versus capital expense, being able to build something and tear it down without it costing you any money is pretty cool, because you then can try new things a lot faster and a lot more. But anyway, I'm going to now talk about how we can implement some of this stuff using Amplify. And what are the features of Amplify? Well, there's two main parts. There's the CLI and there's the client library. The CLI is what you work with from your local environment to create AWS services. And traditionally, if you've ever used AWS, you go to the console and you kind of click around. You see 1,001 services, and you just click on this one service, and you maybe dig around, and you get completely lost, because one out of the 1,000 is something that probably takes months to master. The thing that we're trying to do with the CLI is we're bringing the core services that you can use to get up and running with real-world applications into your command line environment. And from the CLI, you can spin up new services directly, and then you use the client library to connect to those services. So for instance, say you build this new mobile app and you need authentication, you can type a command, amplify add auth, and Amplify push. You now have Amplify has created an authentication service for you, and using the client library, you can then sign in and sign up users within a couple of minutes, and we're going to cover that in just a second in a live demo. So the CLI toolchain does a few different things. It allows you to create AWS services, update and delete AWS services. It allows you to create hosting for static websites and assets. That's not really applicable here. We're talking about mobile, but you can do that. And then it also has different features that do other things that don't have to do with your service. One of those that's pretty interesting is GraphQL code generation. If you've ever worked with the GraphQL API, you know that there's a lot of boilerplate around that. The boilerplate in GraphQL typically has to do around the mutations, queries, and subscriptions that you have to create to interact with your API. The code generation feature will actually just generate all of that code for you. So all you do is run the command, create your API. The code gen will create all of the boilerplate for you locally, and you can just start using it. So it saves a lot of time. And then the client library, it allows you to connect to and interact with the cloud services that you just created from the CLI. It has pre-configured components for popular front-end libraries. We're only working right now, we only have working examples and implementations for web and JavaScript right now, but we're still, we have iOS and Android native kind of on the roadmap, I would say. So the pre-configured components that we have right now work for React Native, they work for Angular, they work for React, Vue, and Ionic. But we are AWS Mobile, so our focus is on iOS and Android. I think they just tried this to experiment with it, and it's been popular, so now we're kind of getting to the native as well. It has built-in support for signature version 4 signing. So basically what that means is when you typically take a request and send it to AWS service, you have a lot of things that go along with the request, security, headers, that type of stuff, JWTs. We actually kind of create all of that for you, and you don't have to kind of worry about it at all. So it kind of supports the signing process. So what are some of the services that you can use with Amplify, or that you can create with Amplify? These are some of the ones that are available right now. So authentication, analytics. Analytics also has a push notification service. So analytics kind of is this service called Pinpoint, which does analytics. It does push notifications. It does SMS and email as well. So you can basically take the analytics and send push notifications, take the analytics, trigger emails, trigger text messages, that type of stuff. That's why it's kind of in that analytics category. We have a GraphQL API that you can create a managed GraphQL service. You can create Lambda functions. You can create and interact with AR and VR scenes using Amazon Sumerian. You can create and interact with chatbots. You can create REST APIs. REST APIs are a combination of API Gateway and Lambda. You can create S3 buckets, so that's storage. You can also create storage in the sense of working with DynamoDB with a Lambda function. And that's kind of all, again, pre-configured in a single command. And then we have an internationalization library, and we have a few other different things in the library like PubSub. And we're continually adding new features, but these are kind of some of the ones that people like to use a lot. So the AWS Amplify Client, this is the client piece. These are the libraries that we support right now. We support any JavaScript application, but we also support Angular, Ionic, React, React Native, and Vue. And iOS and Android are basically kind of also big parts of what we're going to be doing with Amplify. So look for the iOS and Android in the future, like soon probably. And then the CLI. So from the CLI, it doesn't really matter what you're using because you can interact with the services that you're creating using other SDKs. So we have the iOS and the Android SDK that are like AWS mobile SDKs. Amplify is kind of a new SDK, so we can't use that for iOS or Android yet for native. But we also support Web, Xamarin, and of course React Native. That's what we're going to be talking about today. So kind of getting up and running with the CLI. First of all, you install the CLI running npm install -g amplify CLI. You configure the CLI. You do this one time. Once the CLI has been installed, you have to basically let it know about the AWS user that's going to be creating all of this stuff. So you basically run the configure command to let the CLI know which user is going to be creating stuff. After you've initialized or you've configured your Amplify CLI, you can start initializing new projects. So typically you would run Amplify init inside of the root of the project you're working in. So if you're in an iOS project or in an Android project or in React Native project, you'd be at the root directory and you'd run Amplify init. That would initialize the new Amplify project. To add a service, after you've initialized, you can run Amplify add, and then the name of the service, or you can just run Amplify to kind of see all of the services that are available and all of the commands that are available. And then finally, to create the service in your account, you can run Amplify push. Amplify push will just take the local configuration that we initialized, push it to your account, and actually create the real service. Then you can start interacting with it after the push has gone through. So we're going to take a look at how to build an example app, and I'm going to do that right now, like live coding it. Let me see how much time we have left. We should have enough time. So basically, there are a few main parts to most apps. Most apps have all of this stuff, production apps end up with user management. You have to have a backend to handle your data. You typically need search, and you also have reporting. Of course, there's a lot more things that probably are added, but these are core pieces, and these are things that people rebuild and rebuild over and over, right? Every time we build a new app, we need a backend, we need user management. This is where we're going to be taking advantage of some of those managed services. So what are some of the services backing these things? So for the managed API layer, we're going to be using App Sync, which is going to be taking advantage of DynamoDB and Elasticsearch. For authentication, we're going to be using Amazon Cognito. For search, we're going to be using, in this case, we're going to be using App Sync over Elasticsearch. So you could think of App Sync being the proxy over Elasticsearch. And then for analytics, Amazon Pinpoint. So I'm going to go ahead and start with a React Native project. And I have this split up into 3 steps because when you run Amplify push to create a new service, it takes anywhere between 15 seconds to 1 minute. And I want to kind of fly through this, so I'm going to be skipping over the actual, we're not going to have to wait for that because I have each step kind of already set up. But bottom line, what we're going to be starting with is this React Native project here. And we're going to be adding a sign up and sign in flow, like an authentication flow. And then we're going to be adding a data source, and then we'll see how much time we have left from there. So in the root of a React Native app or whatever application, iOS, Android, to start a new project, you run Amplify init. And this is going to be what walks you through a set of questions, basically, to kind of initialize your project. So here it's just asking us what our default text editor is. This is because later on, we're going to be needing to open files, and sometimes the CLI will open the file for us, and if it knows what editor we're using, it'll know the right editor to open for you. So I'm going to choose VS Code because that's what I use. And then it's asking us the type of app. So iOS or Android for native. For anything else, JavaScript, React Native, Ionic, you'll choose JavaScript. Since I'm going to be building React Native, I'm just going to choose JavaScript. And since we're using JavaScript, it's asking us if we're using a framework. If we choose none, then it's not going to take anything into consideration. But we're using React Native. It actually detects that already because it's chosen it for us and it knows we're in a React Native project. The source directory path, this is going to be for any generated code or generated files and where do they need to be put. So for the source directory, I'm going to just choose the root directory because right now I don't have a source or a lib or anything like that. This is just a brand new project. Distribution really has more to do with web projects, or if you have a website within this application that you need to like launch for whatever reason. We're only going to be working with mobile, so I'm just going to choose the default for that because we're never going to really be building a distribution build using the distribution build. The start command, with JavaScript applications, you typically have a start command, npm start. It's already set as the default, so I'm just going to choose that. So really, I chose the default for everything except for the default editor. Chose Visual Studio Code. So now it's going to go ahead and ask us for our AWS profile. I mentioned that you need to have a profile set up when you run the configure, and this will let you choose like what region and what user you want to use. So I'm going to choose yes to use an existing user. I have a couple of users set up. Default is US East. US Central is Frankfurt, which is what I'm going to choose, and then US East 2 for me is the other East Coast region. But anyway, I'm going to be using EU Central. So to start that off, I can just run, I can just click that. And this will go ahead and start creating the project for me. And that will bring us to step 2. And after the project gets initialized, you can then start adding services. So once the project is initialized, we have 2 new files. We have this Amplify folder, and then we also have this Amplify RC file. Both of those are created and handled for us by the CLI. We don't really have to open those or mess with them right now. Down the road, when we add different services that have things like Lambda functions, those will be stored in the Amplify folder, so we can actually update the Lambda functions locally, push them up, and then they get updated in our account. So what we want to do is we want to add authentication, and we want to add an API. So I'm going to run Amplify add API. Well, I'll run add auth first so we can add an authentication service. So we have 2 options. We can either take a default configuration that will give us MFA on sign up and just username, email and password. No, I'm sorry, username and password on sign in. So the default config is basically MFA with your email and sign up, and then email and password for sign in. Or you can walk through your own configuration, and this is basically setting up an entire authentication service for you. So when you walk through, it asks you all the different pieces of information that you would probably typically want to set up in a service like this. So you could add attributes, custom attributes for the user. So you might want to get their home address, or you might want to get their favorite cereal, or you might want to know other things about the user. You can set that up. You can also change MFA types. So if you want to do time-based one-time password, that's supported. You could do things like SMS, MFA. You could do all that stuff. You could even set requirements around their password and requirements around the email that they receive for the MFA. But I don't want to do all that because that's going to take a few minutes or seconds, whatever. I'm going to use the default configuration. And that's it. That's going to go ahead and add a default authentication configuration locally. If we want to go ahead and create this service in the account, we run Amplify push. But we want to add one more thing. We want to add a GraphQL API, a managed GraphQL API. So I'm going to run Amplify add API. So we can either do a GraphQL API with App Sync or a REST API with Lambda. I'm going to choose GraphQL. For the API name, I'm going to call this Conference App API. This is going to be an API that allows you to create conference website or app, and then you can kind of list the speakers and list the presenters and things like that. So for the authorization type, we can choose API key, we can choose Amazon Cognito user pool, or we can choose OpenID Connect after we've set up this initial service. OpenID Connect is what you would use if you want to bring your own auth provider like Auth0 or whatever. API key is basically an open API. Any API hitting this, or any client hitting this API, if they provide the API key in the header, it will be accepted. So it's kind of like not that secure. It will be more used for APIs that you want to make accessible. And then Amazon Cognito user pool is the Amazon Cognito Authentication Service. I'm going to choose API key just to kind of make this basic. And then it's going to ask us if we have an annotated GraphQL schema. I don't, because I'm just starting off brand new. And then if you don't have one, it can actually help you create one. So I'll just go ahead and choose yes, because that might help me out. And then we get two different options for the schema that it can create. It can create like a really basic schema with a single type, or it can create a little more sophisticated schema with one-to-many relationships. I'm going to choose the basic schema though for now. And then it's going to ask us if we'd like to edit the schema. I'm just going to choose yes. And it's going to open up this schema in our editor. So the schema that we want to have basically a type of talk for the conference talk. The talk needs to have a name and a description. So this is all kind of pretty baked in, right? We can just change this to talk. But we also need a presenter. The presenter also needs to have a name and maybe a bio. So we can create a new type of presenter here. And then we can just add the type of presenter as presenter. Whoops. All right, so we have the presenter type with the name and a bio. We can go ahead and save that, close, and then go back to our command line. So now that we've had our two services initialized locally, we can push them up to our account by running Amplify push. Now, since we've just created a GraphQL API, I mentioned that we have that code gen feature. The code gen is going to be, again, what we use to generate all of that GraphQL code for that API we just created. So when we're creating this service, it's now going to prompt us if we want to actually generate that code locally. So I'm going to choose yes. It's going to ask us what the code generation language target is. If you're building native iOS or native Android, you won't get these choices because we're in a JavaScript project. We're getting JavaScript, TypeScript, or Flow. I'm going to choose JavaScript. And then for the pattern, I don't have a source directory, so I'm going to choose GraphQL. And then do we want to generate all the different operations? So if you've ever worked with the REST API, queries or like GET requests, mutations or like put, update, delete, all of the other mutation requests that you would see or posts, I guess you would say. Anyway, I'm going to go ahead and choose yes to go ahead and create all that stuff. So that's going to go ahead and create the API and the auth service. And what we're going to end up with is this step 3, which is where I'm jumping to now. And this is our basic file structure from a brand new React Native app. If you've ever worked with React Native, you'll know that you have this basic kind of starter that just says, welcome to React Native. What Amplify has added for us is this Amplify folder here with this backend with an API and an auth service. It's also added this AWS exports. AWS exports is going to be kept up with by the CLI, just identifies all the different services that are created. And those are like the two things that you'll just need to make note of, just so you know that they didn't come out of nowhere. And then the two files I'm going to need to work with to get this working are going to be index.js and app.js. Because first of all, we need to let the React Native app know about the Amplify services that we just created. To do that, we can run this 3 lines of code to initialize everything. And this is basically going to be the Amplify configuration. So we're going to go ahead and import Amplify from AWS Amplify. This is a JavaScript library, or this is the Amplify library, I guess you would say, that we have installed. We're going to import the config from the AWS exports. This was created again for us by the CLI. And then we're just going to call amplify.configure at a root level. And since we're at the index.js, this is kind of the root level of a React Native app. And you only need to do this once. Once that's done, you can use Amplify any part of your project. So that's step one. Just go ahead and initialize or configure the Amplify project. Now we want to first add authentication. So there's a couple of different ways to go about doing this. You can write your own authentication logic. So you can do things like import this auth component from Amplify. And then you can call, we have over 30 methods on it, so you can call like auth.signin, you can auth.signup. You have all these different methods you can call. I have the autocomplete set up with VS Code, which is pretty nice. But really, we don't have enough time for that. I did mention, though, that we have some pre-configured components for different libraries. So there is one for React Native. So I can go ahead and import this component called, actually, I can just go ahead and use this code snippet I have here. So we're going to import this with authenticator how order component from AWS Amplify React Native. So this is a library that's specific to React Native. Once we have that imported, instead of exporting the class as the default export, we're going to create a new default export that's going to be the with authenticator how order component, and we're just going to pass the app in as the argument. And we're then going to be including a second argument. This is going to be things that we can do to configure this setup that we're going to be given. So with authenticator scaffolds out an entire flow for us. So it gives us a sign up form, a forgot password form, a sign in, all of that stuff. So if I go ahead and save that and I jump back to my app and I refresh, now we get our sign up form, basically protecting whatever component we wrapped with that with authenticator. So now whenever we load the app, we can't see the app until we've signed in. And you'll notice that when we reload, you see a loading message. That's because we're reading from storage. We're checking to see if the user's there. If they're there, we persist their session data. Everything is signed in for pretty much forever until they sign out. So that's kind of handled for you. So I want to sign in, but I don't have an account yet, so I first need to sign up. Go ahead and sign up real quick. Sign up. So now we need to check our email for MFA. So let me use Safari. Well, no, I don't want to use Safari. Let me just do this. So we have a verification code. Sorry, my internet's a little slow. So I'll go ahead and copy that. I'll jump back to my app, just paste that in here. 619284. So confirm. Now we've created a user. I should be able to sign in. And let's look at where that user is. So if you want to know where that user came from, I can go ahead and open Cognito. Go to Manage User Pools and find the mobile era app. Here I have this Dabit 3 confirmed. Okay, sign in. We're signed in. Oh, okay. I deleted this instructions variable and it's still there. Okay, so now we're signed in. The last thing I want to do is add an API. Well, we've already added the API. I'm just going to add the UI for that. This should only take about 1 minute, and then we'll be done with this entire talk. So the first thing we want to do is we want to import the needed APIs to interact with the actual GraphQL API. So the things that we need, there's actually just two main imports we need, API and GraphQL operation. API is the actual API like auth that we're using to interact. GraphQL operation is a helper that takes a query string and turns it into a GraphQL operation. And then we have these two queries. You remember when we created the API, it generated the GraphQL code for us? we're just importing that GraphQL code from here, where we have our mutations and queries set up. So we're importing the GraphQL query and mutation, and then I'm importing a few different components from React Native Elements, which is my open source library. If you ever want to build React Native components, you can use React Native Elements. And then we need some state, because we want to handle the user input for name, presenter name, bio, and description for the talk. So when the user types, we keep up with that info here. And then we want to have the functionality to handle the user input. So we have an onChange handler. This basically takes the user's input, updates the state with the name, description, or presenter name. And then we have a component did mount lifecycle method, which basically means when this app loads, we want to go ahead and fetch all of the data for this API. And then we call set state, and we set the talks array. So we're going to be storing all of these talks in an array, and then we'll render those to the screen in just a moment. And then we have a create talk function that takes a talk object with a name, description, presenter, and then calls the API, putting it there. I'm going to make sure I open, or I'll tweet out all of this code if anyone's interested later, because I'm going to have to run through it real quick. And then the last thing we have is our UI. The UI is basically 4 form inputs, a button, and an array mapping over all of the items that are in our talk. And then I'll update the container just to have some padding. And then we'll refresh. So now we have a little form here. So I'll say talk 1, Amplify, Nader, add talk. If I go to my App Sync API for the conference talk API, and I go to my data sources, go ahead and open my DynamoDB table, click on the items. We now see that we have this talk here, Amplify talk. Was that the same one I just created? Oh yeah, here we go. Presenter, yeah, Nader in Norway. Okay, that's the right data. I was kind of wondering. Anyway, so like our API is working. We're interacting with our GraphQL API. Didn't take much code. Anyway, that's kind of it. I ran a little bit over. I was hoping to kind of like do some more stuff, but that's kind of it on like everything that we're done. So thank you for listening to my talk. And if you have any questions, tweet at me or whatever. I think we'll have a few seconds maybe to ask questions if anyone's interested. Or we're over. Okay. Thank you.